Hello everyone and welcome to another SuncatByte. During today's SuncatByte we're going to talk about generating random numbers. And in order to do that we will use SRand and rand, which are two functions that are available to us in the standard namespace. And remember, in C++, how do we get the standard namespace? We use this code using namespace standard. Okay, so these are what we use to generate a random number. Rand, or SRand, let's start here, seeds the random number generator. What does that mean? It means that it basically sets a starting point for generating random numbers. And it takes an integer value as an argument. For generating random numbers, it takes an integer value as an argument. Something like this. Just takes an integer value. So you're always going to call srand first, and then you'll call rand to actually generate the random number. So then rand is the function that actually generates the random number. All right, and it's going to generate, it's pseudo-random. We'll get into that a little bit more. Not truly random. Basically what that means is if you generate the same, or if you use the same seed, it's going to generate the same values, same sequence. But it's going to return an integer, pseudo-random number generator that returns an integer between 0 and the max rand, which is typically 32,768 or 767. One caveat is if you use the same seed value, you get the same series of random numbers from rand. So if you use the same seed value for srand, you get the same random numbers. An example of how they'll be used is going to be, say, srand 6, and then say you had int number equals rand. This is going to actually generate a random number. Put it in rand. You can say int number 2. Maybe we shouldn't use number 2. Int number 3 equals rand. And there we go. Int number 3. So srand seeds it. That says where we're going to start our sequence of random numbers. And then int number equals rand. That means we're going to get a random number generated here. It's going to get assigned here. We're going to get a random number generated here. It's going to get assigned here. All right. So those two go hand in hand. Say we wanted to have control over the random numbers that we generate. What if we wanted a certain range or something like that? So if we do, we can use the mod operator to control the range of random numbers we want to generate. All right. So say for instance, say I want to generate numbers between 1 and 10. How would I do that? I would say int n, n for a number equals rand mod 11, and actually let's say in this case let's just do 0 and 10. Yeah, 0 and 10. So int n equals rand mod 11. Okay, that's going to give us numbers between 0 and 10. Well, how does that work? It actually works like this. Remember that rand can give us numbers between 0 and max rand, which is 32,767. So say we're looking at things this way. I always like to start looking out. Say if we have 11, 12, do this, 11 mod 11, 11 mod 12, 11 mod 13, 11 mod 14, 11 mod 15, 11, 15. These are all backwards. Try this again, folks, sorry. 11 mod 11, 12 mod 11, 13, here we go, mod 11, 14 mod 11. So say we take these. Okay, we have 11 mod 11. So 11 divided by 11 goes in evenly. So is there a remainder? No. So it's a remainder of 0. What if we have 12 mod 11? A remainder of 1. A remainder of 2 here. 3 here. 4 here. 5. 6, 7, 8, 9. Now what if we go to 21? Mod 11. That's going to be a remainder of 10, right? Now 22 mod 11 goes in evenly, so we have 0. 23 mod 11 goes in 2 times for 22, right? Then we get 1. 24 mod 11 gives us 2. Notice we have a pattern. We can only, and this pattern is going to keep repeating, so we can only ever get 0 through 10, and then here we're just going to keep going 0 through 10. If we would have went the other way with this, say if we did 10 mod 11, that's just going to give us 10. 9 mod 11. Where are we here? 0. 9 mod 11 is going to give us 9, and so on and so forth. So that pattern is going to repeat. So you can only get 0 through 10 for any of these values. So that's if we wanted to go from 0 to 10. What if we wanted to do something else? What if we wanted to go from 0 to 1,000? What you basically do is you always go one number higher. So if I wanted to go 0 to 1,000, then I say n equals rand mod 1001. That'll take us to 1,000. Say I then wanted to go look at decimals, and I wanted to shift this, or have decimal places, and have it be 0 to 0.000 to 1.000. I would take this, and then I would also say n say we'll make this lowercase n here. And then n equals n divided by 1,000. So now we'll get from 0.00 to 1.000. So say this comes up with 1. 1 divided by 1,000 is going to be 0.0001. Say this came up with 1,000. 1,000 divided by 1,000 is going to be 1.00, right? And actually, you should have 0.0 there. You could even take this, say you want it to be from -25 minus 25 to 25. What you do in that case, from -25 to 25, there's a range of 50 different values. So you want to take that range of, first you want to say, okay, I want to generate a range of 50 values. How do I do that? Well, I say n equals rand mod 51. That's going to give us values from 0 to 50. Then I'm going to take that and basically shift it by 25. So now I'm going to get -25 to 25. So anything you get here will get shifted. So say I had 0. 0 minus 25 is -25. Say I had 1. That's 1 minus 25 is -24. So as you can see, everything shifts to the left. Okay, so let's look at a couple examples for generating random numbers. First off, here's a program. And let's get this right there. That's good. So we have a program that, darn it. Yep, here we go. This one first. Okay, so we have the standard namespace in this case. We're going to include seed time here to illustrate seeding the random number generator. So first things first, we say, here's our random number generator demo. Here's a seed, number in either ints, and string answer. So basically, first here are 8 random numbers. We use the time function for the seed value. So if you want things to be truly random, use this for SRAND, or as close to random as you can be, because what it basically does is gives you the time right now since epoch time, which is January 1st in 1970. And so that's constantly moving. So then you're going to get a different value every time you call that, basically. It's the number of seconds since then. We'll actually get into this a little bit later in the semester when we're trying to do time, but for now, if you do this, it's going to give you a bunch of random numbers, or it's going to give you a different integer value every time you call it. So then here we're just saying for I equals 0, I less than 8 plus I, number equals rand, and then cout set with number. So here, this is actually giving us a random number, or this is giving us a random number, assigning it to number, and then we're printing it. We're going to do that for 8 numbers. Now, here we're going to let the user choose. So here we're going to actually, I'm going to input a seed when I run this, and then given that seed, it tells us where to start that sequence. We're going to output 8 numbers. And then we have the opportunity to run through this again. So let's do this as an example. Start without debugging. So here's first 8 random numbers. There you go. They are random. Now, please enter a seed value. I'm going to enter 9. And we get 68, 6151, 18175, 22398, 3382, 14369, 3609, 5940. So this says, do you want to do another set? I'm going to say yes. So remember, first thing, here, please enter a seed. So say I enter the same seed, 9 again. I get the same sequence of numbers. So they're not truly random, right? It's pseudo-random, which is why up here, this very first one, we used time because it didn't give us the time is different every second, or every time you call it, like I said. So please enter seed. If I do it again, same thing, going to be the same thing. So now let's say I enter a different seed of 10, different sequences. So I enter 10 again, same sequence with the 10. Just to illustrate, 9 again, well, I want to put 9 there. 9 there. I should have put a yes, but if you enter 9, you're going to get that sequence. This sequence again with the 68. And just to show that the time does give you a different value, notice this sequence here: 19,822, 23,066. We're going to run it one more time. So 19,822, 23. Notice this is a different sequence. If I do 9 here, we're still going to see the same sequence we saw previously. We ran it with 9. So that's one example of using random numbers, or generating random numbers. Here's the other that we're going to look at. Here we're going to use the time again. And in this case, we're going to use so here, general equation, if you guys want to look at this later, rand mod n, we get values between 0 and n minus 1. So here if we pick 7, we're going to get 0 to 6. So with this, we should see only 10 numbers because we're looping here 10 times between 0 and 6. Here is the example where we're looking to get a decimal between 0.00 and 1.00. So first things first, and here, this should be familiar. We're going to say do 3 decimals. And the number, rand mod 1001, so that's going to give us from 0 to 1000, and then we're going to divide that by 1000.0. Remember, you want to do that double math there, and then so we should get values between 0 and 0.000 and 1.000. Now here is our value between minus 25 and 25, which was also in the lecture portion of things. So number equals rand mod 51. That's going to give us a number from 0 to 50. And then we basically shift that to the left. So we'll get from minus 25 to 25. So let's take a look and see if that's the case. This actually happens in reality. So we start without debugging. And looking first, we were supposed to get numbers between 0 and 6. Yep, those are all between 0 and 6. Here, a decimal between 0.00 and 1.000. All random, there we go. And here, same thing. Let's run a second instance of it. And notice, we get different values from 0 to 6. This one actually has one that's 6. The other one didn't. So just to show you, it is generating them. A different sequence for between 0.00 and 1.00. And then different between minus 25 to 25. These are programs 316 and 317, so feel free to run them on your own. That's it for this SuncatByte. If you have any questions, comments, or concerns, discussion board forum, email, or office hours. Talk to you soon. Thanks. Bye.